All right, welcome. Today we're going to crack open our favorite gadgets and take a look at the real unsung hero inside. The thing that makes it all possible. The double-sided printed circuit board. I mean, have you ever really thought about it? Your phone, your laptop, even the dashboard in your car, they are all crammed with an unbelievable amount of power, and they just keep getting smaller. How on earth do they do that?
Well, the secret is right here, on this kind of humble-looking green board. This is a PCB, and it's basically the foundation, the central nervous system, for pretty much every piece of modern electronics. It's where all the magic happens. But here's the thing, not all PCBs are created equal, and that is where our story really begins. So to really get why this was such a revolution, we've got to go back to the beginning. We need to start with the original design, the simplest form of the circuit board.
So this is it, the original, a single-sided PCB. It's got this insulating board in the middle, and then just one layer of copper on one side for all the wiring. You can think of it like a bungalow, a one-story house. Every single thing, all the components, all the connections, they all have to fit on that one single floor. It's simple, it works, but you can probably guess, you run out of space pretty darn fast. And that is exactly what happened. Engineers wanted to add more features, more power, and cram it all into smaller and smaller devices. That one-story bungalow, it just wasn't cutting it anymore. The single-sided board went from being the foundation to being a huge roadblock. So here's the problem laid out bare. A single-sided board, it's got one copper layer. That means you can't pack things in very tightly. That's low component density. The circuits have to stay simple. And if you want to add more stuff, well, you just have to make the board bigger. You can see how this was becoming a massive limitation, right? But what if? What if there was another way? So faced with this wall, engineers came up with a solution that was just so simple but so brilliant. It wasn't about completely reinventing everything. It was just about adding a second floor.
This quote from our source material just nails the concept. Instead of one layer of copper, you put a layer of copper on both sides of that insulating board. It's literally like taking that one-story house and adding a second floor. All of a sudden, you've doubled your space without making the building any wider. But that brings up a question, right? How do you get from the first floor to the second?
And this is the secret sauce. It's called a via. It's a tiny little hole drilled through the board that's plated with copper. It acts like a little elevator or a bridge, connecting the circuits on the top to the circuits on the bottom. In our house analogy, the via is the staircase. It's the one tiny thing that turns two separate floors into one fully functional building. This little hole, it changes everything. Okay, so let's go back to our comparison chart. Look at that! Now we can fill in the other side. You get two copper layers, which means you get high component density. You can design way more complex circuits. And the big one, for the same job, the board can be so much smaller. It's a leap forward. And this leap wasn't just some theory on a piece of paper. It completely changed the real world. So let's talk about why the double-sided board pretty much took over the entire electronics industry. The advantages are just huge. You get more stuff packed in, a smaller final product, and you can make your designs way more sophisticated. You can even stick components on both sides of the board, saving even more room. Now, while one board might cost a little more to make, the whole project often ends up being cheaper because everything's smaller. And get this, you can use one entire side just for grounding, which acts like a shield against electronic noise or interference. It just makes everything work better. So, where are these things? The short answer is everywhere. I mean, literally everywhere. From the TV in your living room to the printer at the office, from vending machines to the complex systems that run our traffic lights. This simple innovation is truly the invisible backbone of our modern world. So going from one layer to two was a total game changer. It paved the way for the tiny, complex gadgets we have today. But you know how technology works, right? It never, ever stands still. Which leads us to one last really cool thought. And that's where we'll leave it. The idea of adding layers didn't just stop at two. Your smartphone, your computer, they use multi-layer PCBs that are like electronic skyscrapers, with 10, 12, even more floors all interconnected. So you see, the double-sided PCB wasn't really the end of the story. It was the beginning of a whole new dimension in electronics.